Welcome to Chem 110. The first unit begins with a study of matter and measurement. Let's discuss some of the key ideas and objectives for this chapter. We are going to briefly review the scientific method. We're going to talk about a variety of key terms that you're going to need to know. We're going to review matter, and then we're going to get into the math. So some measurement basics, the metric system, significant figures, which are super important for the entire semester, scientific notation, dimensional analysis, again, something that's super important that we use all semester, and temperature and density calculations. The scientific method is defined as the process used to solve a scientific problem. We are going to discuss the steps. Step 1 is making observations and identifying the problem. Step 2 is to create a hypothesis. The hypothesis must be something that is testable in the lab, and it's a prediction. Then we perform the experiment, analyze the data, and we write a conclusion. In our conclusion, we always refer back to whether or not our hypothesis was supported, and we use evidence from the data from the experiment to support or not support this. Here are some additional important key terms that you must know. A theory is a well-established hypothesis. A law is a concise scientific statement of fact. The theory often tells us the why. So why does something take place? Where the law is going to tell us how it takes place. Matter is anything that has a mass and a volume. Volume is anything that takes up space. And chemistry is defined as the study of matter, the changes it undergoes, and the energy changes that accompany these processes. Key terms make great multiple choice questions for tests. Let's continue. Matter. So our three main states of matter are solid, liquid, and gas. These are things you should probably already know. A solid has a definite shape and volume. A liquid has a definite volume but takes the shape of its container, and a gas has neither. Okay. And you can see from the picture that solids are much closer together than liquids, and that gases are very spread out. Additional definitions that are important, again, probably words you've heard before. Elements are things that cannot be changed into a simpler form of matter. These are things that are found on your periodic table. A compound is a combination of two or more elements. For example, something like NaCl. A mixture is a combination of two or more pure substances. Your elements and compounds are your pure substances. There are two types of mixtures. Again, probably words you've heard before. We have homogeneous mixtures, and we have heterogeneous mixtures. Think about the prefixes and what they mean. Homogeneous mixtures are mixtures that are uniform throughout, so they look the same. Heterogeneous mixtures are not uniform, so they look different. This next slide discusses the different types of properties and changes. Again, probably something you've seen at some point in your scientific lives. Physical properties can be observed or measured without changing the composition of a substance. Some examples include things like the color of that substance or its density. A physical change is a change that produces a difference in appearance, again, without causing a change in composition. For example, maybe cutting up a piece of paper. It's still paper, or melting an ice cube. It's still a form of water. Chemical properties are the opposite. Chemical properties result in a change in composition, so we're producing something new. The two main chemical properties that we'll probably discuss for the most part are flammability, so can it catch fire, as well as reactivity. What does it react with? And a chemical change or a chemical reaction is when a chemical substance is converted into something new. So again, we are changing the composition. For example, when we burn something, if you're eating food and your body is digesting it, if something rusts, if you're cooking, all of those are examples of chemical changes. Now, what I would like you to do is I would like you to pause the video and identify if each of these substances is pure or a mixture. If they are a pure substance, identify if they're an element or a compound. If they are a mixture, identify if it is homogeneous or heterogeneous. In addition, identify on the other side of the slide if those examples are chemical or physical. Please pause the video at this time. Here are the answers to the practice problems. Ethanol is a compound. Milk and cereal is a heterogeneous mixture. Oxygen is an element. Lemonade is a mixture, and I put both heterogeneous and homogeneous because if it has pulp, it's probably heterogeneous, but if it doesn't, it would be homogeneous. Ice is a form of water, which is a compound. And then, of course, a jar of assorted coins is a heterogeneous mixture. For the chemical and physical, water boiling, melting ice, and mowing the grass are physical, and the other three are chemical because they're producing something new. Now let's begin our study of measurement. Measurement is defined as the fact that it determines the quantity, dimensions, or extent of something, usually in comparison to a specific unit. Units are extremely important in chemistry because I need to know what is it? Is it in centimeters? Is it in meters? Is it in kilometers? Is it in grams? Is it in pounds? The unit is very important. Every measurement has two parts, a number and a unit. There are two main types of measurement. We have qualitative, which uses description without numbers, so it's telling you the quality of something. And we have quantitative, which uses numbers to describe. It's giving you the quantity of something. This is more common for our class because this is a pretty math-heavy class. Of the examples, these two that I'm currently underlining would be examples of quantitative measurement, and the other two that I'm now circling would be examples of qualitative measurement. Let's talk about some really important terms for measurement. So how good are your measurements? There are two main words that we use to describe this: accuracy and precision. If you're accurate, it is how close a measurement is to the actual or true value. If you're someone that tends to get A's on tests or you earn a 100%, you're accurate. Precision is how close together results are to each other. I like to use the word consistent here. So you're precise if you are consistent. So maybe you get an 85, an 84, an 85, and an 86 on 4 of your tests. All of those values are very close together, so you are a precise person when it comes to testing. You can also take a look at the dartboard here as an example. You can be accurate and precise, so pretty much hit the center every time. You can be accurate once, but imprecise the rest of the time. You can be inaccurate but precise because here all of the points are close together, or you can be neither, where you're all over the place with those darts. In this example problem, if I said, are these values accurate, precise, both, or neither? 10.2, 10.3, and 10.4. Hopefully when you look at those numbers, you think, oh, they're close together. So because they're close together, we're definitely precise. Are you accurate? Hopefully you're thinking, I don't know because I don't know the actual or true value. If I told you that the actual measurement was 10.3 meters, you would tell me, yes, you're accurate. But if I told you that the actual measurement was more like 20.8 meters, you would say, whoa, we are definitely not accurate. Let's move on. Okay. Let's talk about significant figures. This is a really important concept and we use it throughout the entire semester. Significant figures are defined as all of the certain digits, the ones you're totally sure of, plus one uncertain or estimated digit in a measurement. There are rules that we are going to follow. They are here. You are going to want to remember these rules for the entire semester. The first rule says that all non-zero digits are significant. For example, if I gave you this number, there are 4 digits in that number, and none of them are zeros. So you would tell me that this was 4 significant figures. The second rule says that zeros between non-zero digits are significant. For example, if I said this, so 10,002, those zeros are between other numbers that are not zero. I can't just get rid of them and turn 10,002 into 12. So you would tell me that this one is 5 significant figures. The last two kind of go together. If there is a decimal present in the provided numbers, the zeros at the end of our number count, regardless of how many there are. For example, if that's the provided number, to determine its significant figures, you're going to go left to right. You're going to go to the first one that's not a zero, which is the 2. And everything, including that 2 after it, counts. So this would be 6 sig figs. This also holds true if the number was something like this. 40.0. Again, the first non-zero digit you see is the 4. That 4 and anything after it counts because of that decimal. So this one is 3 sig figs. If the decimal is absent, the zeros at the end of the number do not count. For example, if you had this, 402,000, you would say, oh, the zeros at the end don't count because that's what the rule says. So this 2 to the 4 do. So this would be 3 sig figs. What I would like you to do is, using these examples and these rules, pause the video and try to determine how many significant figures are present in each of these practice problems. Please check your answers. Hopefully the first 3 were okay, not too bad, as well as the second to last one. The 2 that I have circled are 2 that usually kind of give people a little bit of trouble because we didn't really discuss them. So here, in the one that's 6.030 times 10 to the second, this is 4. And because of this decimal, that's 3.